Have you ever looked at a sand dune or a vast desert landscape and wondered what incredible forces shaped those magnificent formations? Our planet's surface is constantly being sculpted by powerful, often invisible, agents. Aeolian sediment transport mechanism refers to the process by which wind erodes, transports, and deposits loose sediment particles across the Earth's surface. It is a fundamental geomorphic process, especially prevalent in arid and semi-arid regions, coastal areas, and paraglacial environments. The core mechanism behind aeolian transport involves the transfer of kinetic energy from moving air to sediment particles. When wind blows over loose material, it creates shear stress on the surface. If this stress exceeds the forces holding the particles in place, such as gravity and interparticle cohesion, the particles become entrained or lifted into the airflow. The effectiveness of this process is directly related to wind speed and the size and shape of the sediment particles. Understanding aeolian transport helps us interpret how landscapes evolve. There are three primary modes of aeolian transport: surface creep, saltation, and suspension. Surface creep involves larger particles being rolled or slid along the ground by the direct force of the wind or by impacts from other moving grains. Saltation is the bouncing or hopping motion of medium-sized grains, which are lifted by the wind, travel a short distance, and then fall back to the surface, often dislodging other particles. Suspension occurs when very fine particles, like dust and silt, are lifted high into the atmosphere and can travel thousands of miles before settling. A fascinating insight is that saltation is not just a mode of transport but also a primary driver for the other two. When saltating grains impact the surface, they transfer energy to larger particles, initiating surface creep, and to smaller particles, kicking them up into suspension. This interconnectedness highlights the dynamic nature of wind-driven processes. Factors like vegetation cover, soil moisture, and surface roughness also play crucial roles, influencing the threshold wind speed required to initiate movement and the efficiency of transport. Ultimately, recognizing the intricate dance of wind and sediment allows us to predict and mitigate issues like desertification, soil erosion, and dust storms. By understanding how particle size, wind energy, and surface conditions combine to dictate movement, we gain a deeper appreciation for the powerful, yet delicate, balance shaping our planet's diverse landforms.